we are going to do the last example on principle of work and energy. And then we are going to go for conservation of energy. Okay. So if you go on to Avenue to Learn, I hope I've uploaded the file that's needed. Hold on. Let me check. So if you go to week 14, okay, examples, we have 3 more examples to do, and then we are done for this course. Okay. So if you could upload these examples on your tablet, on your computer, it'd be fantastic. Okay, so let's look at example number 1. Okay, and this example is based on conservation of work and energy. So let's look at the diagram over here. The 10 kilogram rod AB is pin connected at point A and subject to a couple moment of M is equal to 15 newtons per meter. So this is our coupled moment, and this is our rod, and this is where point A is. If the rod is released from rest when the spring is unstretched at theta is equal to 30 degrees, determine the rod's angular velocity at the instant when theta is equal to 60 degrees. Now, this next point is important. As the rod rotates, the spring always remains horizontal because of the roller at support C. Okay. So for this case, we are going to work it based on, so we're going to solve using principle of work and energy. So the formula that we are going to work with is equal to T1 plus by summation of work done from first point or first situation to the second situation equal to kinetic energy at the second situation or condition. Okay. So first we define T1, or when theta is equal to 30 degrees. Okay. So the condition is T1. Okay. So when theta is equal to 60 degrees, okay, the condition is T2. Okay, I'm teaching, I have to write this. When you write for your exam, you don't need to do this. Are we clear? Okay, I'm teaching, that's why okay. So we know that the kinetic energy, so it tells us an important thing, that the spring is unstretched at theta equal to 30 degrees. Okay. So we know that T1 is equal to 0, i.e. the spring is still unstretched, okay, and there's no torque. So next we are going to look at summation of work done from 1 to 2. So this is our work done. So given to us, so the work done is done by what? Okay, two things are doing the work. Okay, so the work done is done by the rod moving. Okay, the work done is done by the stretching of the what? Stretching of the spring, and the work done is also done by the moment. Okay, so let's consider work done by the moment. Okay, so we know the relationship where U moment is equal to m theta. And take note where theta is in what? Radians. Okay, so you don't take theta as in degree. Okay, so let me get this diagram so you can see better. Right, so we are going to consider this 15 Newton meter. So we know that this is equal to 15. And there are two angles that we're going to look at. The final angle is 60 degrees. The initial is what? 80 degrees. So it's 60 minus 180 multiplied by pi, then minus by 30 over 180 multiplied by pi. And then this whole term will be equal. Now, why I multiply by pi? Because I'm changing to what? Radians, okay? Last year, a student asked me in the exam, what is radian? If you're going to ask me that question, you know what will happen to you? First of all, I will hit you really hard, and I'll tell you I don't know. Okay, 7.854 joules. Okay. Now, this moment is positive because it's the work what? Work done. Okay, work means work output. Okay. Then the next thing we have to consider is work done to move the rod. Okay, to move the rod due to its own weight. Okay, so down here, you have to be really, really careful. Okay, work done by the rod, you have to consider the center of gravity. Let me spell this out. Center of gravity position. Okay, all of a sudden I cannot spell position. Okay, so it's from the center of gravity position, or we call G. So for this case, G is exactly over here. Okay, so this is where our G is. Okay, so the U of the rod, the work done by the rod, is equal to mgh, right? So I put here again h from center of gravity. So we know that the mass is 10 kilogram times by 9.81. So now the h, one is at cos 30, the other one is at what? Cos 60. Okay, so 0.75. We have to divide by 2 is because this is where at midpoint is where the what? Center of gravity is. Are we clear? Okay, so cos 30 minus by 0.75 divided by 2, cos 30 again. Oh, cos 60. Okay. What is equal to 0?
Same thing before. Like when it was cos 30.
Okay.
Easier.
Where you change the cos 30 to cos.
Oh, cos 6. Okay. So times 0.75 divided by 2 minus by 0.75 divided by 2 times by cos 60 times by 9.81 times by 10. Okay, so it's 13.465. Yes. Yeah. Okay. So from here, we are going to look at the work done by the external spring or extended spring. Now the spring is going to cause a resistance to the weight dropping of the rod and the moment. Agree or disagree? I make a statement again. The spring will oppose the applied moment and the weight of the rod. Agree or disagree? Right? So this spring will wants to pull itself what? Will want to pull the rod in a vertical position and will both what? Oppose the applied moment. So therefore, when you were to calculate the work done by the spring, it's no more positive, but it's equal to half Ks squared. Okay. Why is it negative? Because it's opposing the weight of the rod, the work done by the rod, which is positive, and the moment is also what? Positive, right? The moment, if you look at the moment's in what direction? It's in the clockwise direction, and it's following the direction of the weight that is dropping due to what? Gravity. Yes or no? Okay. So the spring, however, what does it want to do? The spring will want to what? Pull it back. Okay. So when that's the case, now all you need to do again, you want to find the extension of the spring now. Okay, so at certain position, so you want to find this spring extension. Okay, so this will be equal to half. Stiffness is given to us at 40. Okay. Now this is not taken at center of gravity anymore. Yeah, it's taken at the edge of the spring. So you have 0.75 sine 60 minus by 0.75 sine what? 30. Yep, and a square. So 0.75 sine 0.75 times by sine 60 minus by 0.75 times by sine 30 squared times by 40 times by 0.5. Okay, I'm not getting the right answer. Wait, squared times by 40 times by 0.5. I got 1.5 minus 1.507. There's a minus sign down here. Okay, can you not forget that? I did forget. So minus 1.507 joules. Okay. So from here, is there any more work done in any system? Nope, that's all. Okay, there's nothing else to consider. So the next one, the T2. Before I go on, anyone, any question? Are we okay? We're good. Okay. I know this looks really, really easy. It is compared to what you guys have done before. So from here, we want to calculate T2. And the thing to take note regarding T2 is the rod is rotating about the fixed what? Axis at point A. Am I right? The fixed axis at point A. So this is equal to T2 will be equal to half IA, okay, omega squared. Okay. So I'm going to take IA, mass moment of area at A is equal to IG plus by what? MD squared. Okay. So this will E be equal. So I have to write down the formula. So it's 1/12 ml squared plus by MD squared. Okay. So from here, this will be equal to 1/12. Mass is equal to 10 kilogram multiplied by 0.75 squared plus by the mass is again 10 kilogram. Now, D, you have to be really careful. Okay, the D now, right, is from the center of gravity is equal to 0.75. And this will be squared. Okay. So this will be equal to 1/12 times 10^75, 10.75, 10^75, 2 times 0.75 divided by 2 is equal to 1.875 kilogram meter squared. Or you can do IA is equal to 1/3 ml squared. So if you do 1/3 ml squared, the mass is what? 10 kilogram. The length is 0.75 squared. You should get the same answer. 1.875. Okay. Now this is from our where? Our table. Yeah.